about applying social network analysis methods in R. And very first thing that I would like to share with you here is that I've already told you about this book that was written by two researchers, and actually it's like one of the best like practice books dedicated to this topic, because you see that these two researchers are the founders of iGraph package in R. So I can truly recommend you this book, and I personally used it like many times, and I like the way that this book was written, and I like really the references, the sources, and you see that here you can also find the codes, and you can represent everything that they got here. So actually you see that these researchers, they start from the very beginning. Like you see that here you have like really foundations of the whole network analysis thing. And after that, you see that the first part to the R codes in general. And after that, they used like several methods to work with network data. And you see that they provide a really like great the great workflow to work with the network data. But you should like here can't open PDF file. This book is in your okay. So well, I will try to fix this problem later. Okay, so I will send it to you somehow. So yeah, so I can totally recommend you this book. So it's really easy to understand, and you see that all the workflow is just amazing, and you see that there are lots of many things about network visualization, for example. I really like this part about visualization. For example, you see that there are many layouts that we can use visualizing our results, and you see that here you can create this network structure is like really simple, and it's not like really beautiful, and using these code lines you can create such an amazing picture. So yeah, I will send this book I will try to find something. Okay, so let me just find it in my computer. So maybe I will give you a simple task, and during this time I will find something. But also I have created this really handy thing for you, and it took me a while to do it. So I really will be happy if someone will use it in the future. So this is a handout that I've created. You see that we have here contents. The first section is dedicated to introduction to R. Here we have some basic concepts, basic objects. Yeah, thank you, Daria, for sending this handout to the chat. And you see that here we have like very basic things. So if you have this prior experience in R, you can just skip it, obviously, because everything should be really clear for you. But if you're really new to this program, please don't be scared, because you should understand this program as a really difficult calculator. It's not like really difficult. I can say that I'm not really like technical guy, but I can understand all of your really scary thoughts about this program, but please don't be. And if you have like any problems, please text me in the chat, or like or like just turn on the mic and tell me that something was wrong. Okay. So the second section of today's workshop is dedicated to the network data. And here I should say that if you have this prior experience in R, it will not help you because the network analysis in R is really specific as a whole network analysis approach. Because you see that here we should have like specific network objects, specific like types of objects. We should create some this object in a really specific way. So we will talk about it today. But I am trying here. The idea behind this section is to like make you like see the network. So the really important part in this section is dedicated to the visualization of your results. So yeah, we can calculate some basic statistics. We can say something about our network, but I would like you to create this network because I can say that this is the most exciting things about networks, plotting the networks, creating and dragging the vertices. It's like really the best one. And also we have this section, other ways to plot, where we have 3D plots, a network movie, and interactive plots where we have Harry Potter. So we will create a network based on Harry Potter movie, and yeah, it will be like really, really great. So we will start with this gentle but really like fast introduction to R. Please, again, don't be scared, and we will do everything like in a really gentle and really calm, relaxed way. So if you are new to R, you should understand that this is the place where we should write our code. For example, we can write here comments and we can use this comment to return, and here we will have this output. We can also like use this as a calculator. We can like sum 1 and 5. We can make like other operations. We can calculate the exponent and the mean. So here you can see that this is a really like cool calculator where we can calculate and even find some like statistics as standard deviation, maybe variance. So it's like really easy for you to understand because you see that we have here functions, but it's like really calculator. But we can also create objects in R. So object is basically a container. We can place in our container 5, it's a like single number, single value. Also, we can place like this container another number, okay, but we can place also here a vector. To create this vector, you should place here C to like, if you want to, if you try to like do it in this way, it will not work out, okay? So if you would like to like put lots of numbers, you should put here C, okay? And it will work. Okay, so vector is like the basic network, the basic object structure, object type, okay, in R, and you should like know it for sure that we have a place where we have lots of many values. Also, we can use this semi column here, and we can use all of the numbers from 5 to 15. We can also calculate the length of our vector. It's like the number of values that this length, this vector has. And you see that we have here 11 numbers, and also we can like calculate the mean of this factor, we can calculate standard deviation. We can even like calculate the median and all the other things. But the very important thing that we should know that if we, for example, would like to know what's the third element in this vector, we should place here vector, and in the square brackets we should press 3, and you see that it's 7, and it is 7 actually. The third element of this vector is 7. Okay, we can also use this really handy function that is called seq, and we can create some sequences. For example, here we create a sequence within this range, and we gradually add some like number, it's 1.25 to this first number here. It's like not really also difficult, and also we can for example understand what's the length of our vector, and you see that the length of our vector is 21. So there are 21 elements. You can also see it here. There are 21 elements within our list. To understand this function better, you should press this like mark here, and you should place here seq. So after this, you will see that here you should this special like information about this function should be, and you see that here we have like this function, we have some arguments from 1 to 1, and you see that here we have sequence from 0 to 5, and we have this argument special called by. Okay, so you see that by is a number increment of the sequence, and yeah, you should like, for you it should be like okay to use this function, because I think that I use this function like lots of many times when I do not understand how a particular function works. So also we can create matrices. For example, here you see that we have a matrix that is full of zeros. To understand how this function works, you should also press here quotation mark, not quotation mark, a question mark. And you see that here, this function, we can see that this function creates a matrix from a given set of values. And you see that here we have a function, and inside we have some arguments. And to understand how this function works properly, okay, you should always use this procedure, okay? And also we have like this matrix, it's also a matrix, and there are lots of many values, and this matrix is full of zeros, okay? So you see that we have some objects, for example, number A, we can find the class of our object by using class function. We can find the class of number A, and we can similarly apply this class function to every object that we have created right now. You see that number B is like a number A is like also a number, and the class of this object is numeric. But we have created also a matrix. That's why we expect that it's gonna be a matrix. Okay, it's a matrix. It's a typical form when we use this class function to the matrix. And you see that this is actually a matrix. So matrices are really important for us actually, because matrix is a really common way to represent the network. And we will talk about it like in a few minutes, but you should remember always that you should understand what a matrix is, because this is a really common way to describe the connections that we have in our network. Okay, so we can like multiply these objects. This is not really like interesting, I think, that you should understand that we can find the intersection, we can find the values that are in both vectors. For example, in vector C, we have this 1, 5, 8, and you see that also we have these numbers in vector D. And these are the numbers that we can find in both vectors. We can find mean, median, standard deviation. It's like not really interesting for you. If you would like to like find all of the explanations, again, I have created for you this handy handout, and you can like find all the explanations here. And yeah, I think that it will be really great for you to understand and read everything that I prepared for you. So, okay, let's move further. You can like contain all of the things. For example, you can find, for example, let's create a vector. Okay, 1, 2, 5. I would like you to, for example, find the mean, and it's gonna be like a number. Okay, it's 3. And I would like to to calculate, for example, the exponent with this argument. Okay, so actually here I have 3. Okay, so it's like a baby doll, Russian baby doll. So, okay, you should understand that it is kind of nested. So I can put something here also. For example, let's put it in the third, in the power of 3. Okay, so I have this number like 20, and I put it in the power of 3 and divide, for example, to 2. Okay, so it's something that you should understand. Okay, so we can create objects from operations. It's like you see that as it is like a vector, you can write this vector and create the object. It's like really obvious thing for you, I think. And so we can calculate variance. We can even divide this number to like 23. Okay, and it's gonna be a number. Because you see that here we have one number and we multiplied it to the other number. So we basically multiply one number 5 to the other number to 2400, and we divided it by 3 and we got something, and we save it in the object called other number. Okay, so it's like a really great calculator, but it's not like really difficult. Okay, so well, this part is not really like obvious for me. We can recode variables. For example, we have here lots of like values. It's a vector. We can find it right here. It consists of 21 objects, and you see that we can even find the length of this vector, and you see that here we have 21. It's great. Okay, we can find mean and everything, median, and okay, everything, median. Okay, so it's like something that we just did, and it's not like, again, really interesting, but we have a vector, and you see that there are some values that are not unique, and you see that here we have like 4 values, I would say. And we can use this really handy function called recode, and we can like tell R that we want 1s and 2s be 2s and 3s and 4s be 1s. And you see that, sorry, unreplaced values. Okay, So you see that here we have variable a. Let's check what's inside. Okay, we have here ones, twos, zeros, and fours, and you see that we have a warning here: unreplaced values treated as an ace. Okay, so maybe we have like some problems here, but let's check what's inside. I think that we missed something. For example, I think we should put it like here, maybe. Oh, maybe. Oh, okay, I got it. So I didn't load the car library. Okay. So let's do it like again, maybe. Unreplaced value is treated as an A. And if we put it like here, we got the really similar situation. Okay. So to like, you see that we have a really common thing here. We have a problem. To understand this this function like properly, you should maybe use this car thing. Okay. Okay, we can like read about this function, because you see that this function worked properly here. Yeah, you see that it's like right here. Okay, we have a like warning here, and you see that here we have this function called recalled, and we should put numeric factor here. You see that variable a is a numeric factor. It's totally okay. And after that, we should put recalls here. And here are the way, it is the way we can use this function. Okay, so we can put something like that. And this variable should be recorded based on this information here. You see that here we put this information, and all ones and twos, they have become twos, and all threes and fours, they have become ones. The original code mold my computer. Okay, great. That's really cool. And let's put it like in this way. Okay. And you see that this is original code. Maybe I have something on my computer, but I used this code like a couple of hours ago and it worked nicely. So I think that this code line should work on your computer. So we can do the similar thing using like other formats, and it will also work nicely. Also, we can use multiple manipulations within our data. We can replace it not by numeric numbers, but by character values, for example, low, high, and you see that here I have this warning, but on your computer it should work nicely. I should maybe reopen on my RStudio, but I will not spend this time on this part because it's not really important. It should work nicely on your computer, and here you see the output, and you see that when we recode our vector from low to high, we just simply we should simply tell R that 1 and 2 will be low, 3 and 4 will be high, and this function will just helps us with the recoding. And you see that one has become high, 3 has become low, and you see that it's also really easy to understand function, but it's really handy, and I think that it's really like one of the most used functions that I have like in practice. So after that, we can use this as functor function, and we can see that we just created levels, and you see that these are these unique numbers, and you can use these levels further in the analysis. For example, you can just order these variables and see that 4 is larger than 2, 2 is larger than 3, and 3 is larger than 1. Okay, these are the levels, and we can make them ordered. Okay, so after that, we can create like here vectors as we just did, and we can find like as we did this specific elements, for example, the fourth one, or we can find the first, the third, and the fifth. And we can also find the length as we just did. And we can sum these objects, and we can make the manipulations that we made, and we can make this summary. This is the distribution of our numeric variable. And we can also find this cumulative sum of the vector, and some like basic manipulations. It's like calculator, as I told you. And well, this is the really important part, that we have here nominal and ordinal variables in R. Here you see that we have like a character vector. Okay, so it is a vector that consists of character variables. And we can use the function that is called factor. You should for sure see what is this function is about. So this function is used to encode a vector as a factor, okay, in terms of categories. So here we have basically categories. Here we have countries, I guess. And they will be used as factors, okay? So here you see that we save these factors, right? These unique variables in the object called T, and you see that here are the factors, and you see that we have here levels. You see that these are unique numbers, and it's important that they're not ordered because we have character variables. But also we can make this factor, we can make the factor numeric, and it's also really important that you can create this numeric vector from the factor, but you cannot make a numeric vector from the vector that consists of character values. So it's really important procedure, and you will use this procedure a lot when you will construct your networks, and when you will work with the attributes and assigning attributes to the nodes. So it is really nicely created workflow for you guys. So here we have like these levels, and we have this function calls levels, and we can find this as integer levels here. And also we can find some specific factors. Thank you. Thanks a lot, Daria. Please, guys, pay attention that Daria just found this book that I recommended you a couple of like minutes ago, maybe half an hour. Okay, and you see that we can recall the numbers, we can assign specific names to this factor, and you see that here, for example, we have basically two vectors. Here we have two vectors. The first one consists of 1, 2, 3, 4, 5 elements, and we have like some categories here. The second one also consists of like 4 elements, and we can create a factor, and we can these values are levels, so they're unique. It's really important. And S is the vector that we would like to create a factor from. And so we can say that they are ordered. It means that unsatisfactory is worse than poor, and poor is worse than average, average is worse than good, and good is worse than excellent. And you see that we can do it, these ordered levels that we have, and we can make this integer number from the vector. Okay, thank you. Thanks a lot again. So also, if you're Russian, you can create a vector called привет and say that inside there are lots of words like R, R. Well, it means that R is a Unicode language. So let me just put the final words E. Привет. And you see that here we have like a variable called привет, and we can pass it, and we see that there are 3 elements inside this vector. Okay, so the final part of this fast, not really gentle introduction to this R programming language is that here we have the opportunity to work with data frames. A data frame is a really important type of data. Yeah, it's really important objects. And we can create data frames, and you see that here we have these data frames. We can even open this data frame called D. It's an object, and the class of this object is data frame. We can find the class of this object here, and you see that this is data frame. We can create a matrix from this object. For example, we can find the class of a matrix of D. And you see that we can create a matrix, and after that, well, it's a stupid procedure, but you see that we can create a matrix and find the class of the object that is inside. Okay, and we can even plot our data frame, and you see that here we have 2 variables, U and V, and here we have U, here we have V. It's not really like a smart picture, but you see that we can plot it if we have 2 variables. We can also find the specific elements from our data frame, and we see that we can extract the second item in the data frame. And you see that we can extract this V column here. Also, we can extract the second column from by applying this function. You see that the same result, but you see that here we would like to see the second column of our data frame. But if we press here 1, we will find the first row of the second column. The first row, the second column, yeah, it's 1. It's okay. But if we would like to find the first row, it will be like this. So 1, 1, the first row. But here we're interested in the second column, so we will save it here. Okay. So a data frame D can be created also interactively by using this really handy function. And you see that here we can put all the numbers, everything that we would like to use, but it's, well, not really commonly used, but you can do that by using this edit function. Also, there are lots of packages in R, and let me just briefly describe what is the package. Package is like a bag with a function. So here you see that we previously used many functions, but if we would like, for example, to use some specific function that are connected to network analysis, for example, these functions are really specific, and we have like specific packages like dedicated to social network analysis, time series, like whatever. And we have this like full package of functions, and we can use some functions like we will just in a minute. So if we would like to use like specific type of analysis, you should install like some packages to your computer and load them by using library function, okay? So I just don't know if you want like this really big list of details. I know that some of you like do not have this experience in R, but if most of you do have experience, I think that we can skip this part. Well, but this is the final part of this introduction, and please don't be shy if you like have any questions. It will be just okay for me to like explain you something. And you see that if you like you have a specific package, for example, iGraph or SNA, you should install it on your computer just once. So if you install R, you should install package to your computer, and it will be somewhere inside of your computer, and it will be always here. So you should do it just once, okay? So if, for example, you have never used SNA on your computer, you can like press here. Let me stop it now. Wait, okay. And let me just tell you how you can do that. So let's imagine that I've never used iGraph package on my computer. And you will have like a source of warning. So the first thing that you should try is to put the library and the number of package. And you see that there are lots of many packages. There are really like hundreds of them. And we are interested, for example, in iGraph package, iGraph data. And you see that I do not have a warning. It's like, it's okay. It's just an output that everything is all right. But if you have like a message that I don't understand what is the iGraph, you should install it on your computer, and you should do it in the console. It's really important not to put it in the script. You should put here install packages, and after that you should put these quotation marks, and you should like put here iGraph. And you see that if you see that one or more packages to be updated, currently loaded, restarts are no, I do not want to restart my computer, restart this program, but you see that I can install it again, and you should have like something similar. And the final message should be the downloaded binary packages are in like some place on your computer, and it should be okay. Oh, we have a question. Sorry, a dumb question. Can we create virtual environments like? Well, actually, there is like we have this cloud version of R that is called R Cloud. Or let me check it. Check it like. Well, I think that it's R R clouds or something like that. So let me check it after when we have a break. Okay. So I think that it is possible actually, but it's not like really common and why so widely used as in Python, because when we use Python, we can just briefly put Jupyter notebook and everything will be just fine. But if you use R, it will be like really more convenient for you to install it on your computer, because you see that you will face lots of problems. You will face lots of problems with LaTeX. You will face lots of problems with packages. So please, well, you can try and you can fix all of these problems, but in, for example, Stack Overflow, there are not so many like answers to this question. So I recommend you to install R. Okay. Okay, so I hope that you are with me and you are listening to this final part of our presentation. So this final part will be really funny, and let me just ask you here kindly to help me with all the interpretations. It's like really not really difficult. And you see that here we will construct lots of networks and we will understand the basic idea behind this construction. I totally understand that you are like doing it, most of you for the first time, but don't be scared, okay? Don't be scared. And also in the final part, we will create a movie. And after that, we will create this Harry Potter network. It's like really great, guys. Okay, so let's start with the very beginning, and let's see how can we, how is it possible? How can we construct our network? Okay, so let me put it somewhere. Okay, so I will delete this part and let me just briefly tell you how can we work with our packages and libraries in R, like the general idea. Okay. Okay, I will tell you that this is the general idea behind social network analysis in R. So you should understand that there are actually two libraries that we will use during our course, and these libraries are the most important and the most like common. The first library is called iGraph, and this library like is really important, and I would say the most popular. This book that I highly recommend it to you is based on this iGraph package, and it's really like great for beginners, and I just really like this package for the crystal and really like clear idea behind the construction of the networks. So to work with iGraph packages, you should create like iGraph objects. So if you would like to apply iGraph functions from iGraph package, you should have this iGraph object. To create an object, you should have a matrix. So the very first, let me put it another way. iGraph package, iGraph object. Next, SNA package or network package. And you see that SNA is inside of network. You should use network object. But you have to know that there is a really strict algorithm how to construct a network in R. The very first thing that you would like to, that you should do actually to construct a network, you should create a matrix. Create a matrix. And let me remind you something about our matrix. And you see that we have like matrices. And let me show you how we should understand these matrices. And you see that here we have matrix E, for example, and this matrix is like the basis of, it's maybe a basis of our network, because you see that here where we have like number of, where we have our row names and call names, it's really important that our matrix should be quadratic. So the number of rows should be like identical to the number of columns, and the names should be identical also. So if, for example, here we have 1, we will have a connection from the first vertex, the first node, to the second node, and we will have this connection. If we like have a connection from 2 to 1, this link, this connection will be mutual. So we will have a connection from the first node to the second node, as well as from the second node to the first node. Are you guys with me? Is it, guys, clear for you?
Yeah, yes, it is.
Okay. So for those of you who have prior experience in social network analysis, these things is like really like should be clear. But I understand that most of you like doesn't have this experience, and that's why it's really important to get this. So we should have this matrix. This matrix should be quadratic. Okay, so the number of rows should be identical to the number of columns, and this the names of the columns and rows should be identical. So create a matrix. The matrix should be quadratic. So quadratic means that a number of rows should be like the same with the number of columns. So if we have a matrix that is not quadratic, it's like a really bad thing. So you should think about it a lot. So if we have like this matrix where we have zeros and ones, 1 stands for connection, 0 stands for like no connection between vertices, we can create a network. But before we create a network, we should decide whether it should be an iGraph object or a network object. If, for example, we would like to create an iGraph object or network actually object, you can think that it should not always be a matrix. Okay, it may be also an edge list. Edge list is like a special format, is a quadratic matrix called the adjacency matrix as well. Yes, it's an adjacency matrix. So this matrix is adjacency matrix. Okay, great. You're doing great. So also, if we, for example, let me just open some like example here. Here you see that we have like a network here. Okay, we can put the summary, and you see that this is an edge list. This is the edge list format when we have 2 columns, and actually you see that we have a connection from node 5 to node 1, from node 9 from node 1, and all the connections that we have, they are just listed in this edge list format. But I think that edge list is really easy one, and it's easier than adjacency matrix. Okay, so we have like these two most common, I would say, network formats. And after that, when we have this list of connections, we should decide what objects that we would like to use. We can use iGraph objects. And if we use iGraph objects, we should use this iGraph package and iGraph library. And there are lots of functions that we can use to create this iGraph thing. So then we apply, like if we have this matrix, we will apply the function from the iGraph package called graph from adjacency J and adjacency matrix, as far as I remember. Let me check it. Okay. Okay. Graph sorry for this. Graph from adjacency matrix. So you see that here we have this function. And if we use this iGraph package, we should use this graph from adjacency matrix if it is a matrix, yeah, right here. And after applying this function, we will have iGraph object, and we can plot this object, and we will have something like, I don't know, something like that. We will have a network, okay? And we can use all the other fancy functions from this iGraph package to work with this data and this format. But if we would like, let me just put it something like that. Create, let me put it this way, specific objects, because networks are really special. We can use this graph from adjacency matrix, or graph from edge list. It's really similar. It's an iGraph object. Are you guys with me?
Yes.
Okay. So here we have iGraph object. And to create this iGraph object, you can like use this function for matrix, okay? And also you can create network objects, and you will use like specific function called network. It's a network object, and you can use the function called network, or as network is also appropriate. Network, and you should also put this matrix, okay? So to create like a network in R, you should have this really important thing. You should have this matrix, or you should have something that is similar to matrix like edge list, okay? So here we create a matrix. I would say that this is really the most important thing, but after that we should decide here. So it's a choice, okay? Yeah.
When we create a graph from adjacency matrix, how do you encode directions from? I mean, I understand. You get it right? Yeah.
Yeah, I understand it totally. It's a really great question, actually. Let me show you how this function works. Well, I think that I should restart my section. Okay, but you should put this function here, and inside of this function where we like have arguments or something like that, you should put directed false, okay? And your network will not be directed. But let me tell you something really important. You see that here we have like the main diagonal. It's like from linear algebra. It should be really like, if you have like mathematics in university, it should be clear for you. This is the main diagonal of your matrix, okay? Please don't be scared about linear algebra. It's like not really difficult. You see that this is the main diagonal. And if all of the connections that you, for example, will have symmetric, if from 2 to 1 and from 1 to 2, there is a connection and all the connections are symmetric, your network will not be directed because all of the connections are mutual. And we can replace these mutual connections by a simple line that like doesn't have this connection. But if, for example, we have a connection from 1 to 2, but we do not have connection from 2 to 1, your network will be directed. And it's really important to understand if your network is connected or not. But it's safe to like create a directed network at first, yeah. And after that, you can like find all the diodes, how many diodes that you have like mutual, but if you have at least, if you have one asymmetric diode, your network will be directed, okay? So if you have like all the connections that are mutual, but just one connection that is not mutual, like from 2 to 1, but not from 1 to 2, that your network will have a direction, because you cannot like simply transform your network, because you will lost the data and you cannot, you will commit a crime, okay? So you shouldn't do something like that. So you should at first create this, you can find this, there is a function called is-symmetric. You see that it's from base package. And you can place your matrix here. And if the output is true, okay, it's safe for you to create undirected network. But if your output is false, your network is directed, okay? So this is really handy function for you.
Thank you.
Well, sometimes you just see that, okay, it seems that most of the connections are mutual, but no, you should be sure, really. Okay, so again, you should create a matrix, and after that you should create specific network objects, and after that you can like make everything that you would like to make, like create statistics, plot the network, play with the centralities, calculate everything, but done. But here you should decide, yeah. And here I will say I would like to say you one of the most important things, okay, here. So please pay your attention right now to the words that I will I'm going to say you, okay. You cannot, well, just please trust me, you cannot use functions from network package to the iGraph objects. So please, I will save you just like a really big amount of time. So please understand this and remember it's like always that you cannot apply functions from this package to this object and vice versa. You cannot apply iGraph package functions from to the network object. You cannot like use functions that we will use today to the other objects. So if you have like iGraph package, your object should be also iGraph. But if you have like network package or SNA package, right, the object should be network. You cannot like do this thing, okay? And this is, I would say, the most common problem for those who like start this journey with programming and network analysis with R. So please trust me, this is like the most important lesson that I would like to share with you today. Okay, so we have like this network thing, and I hope that you understand the idea behind. Okay, I hope that you understand the idea behind this and the logic behind it. So let me start and let me show you my favorite examples of networks. And again, let's see how to create this network. So let's it be like really easy for you. So we have network library. Okay, so this is like not really important function. It's for the output. It's for the tech output to make this output really nice. Okay, we have network library. That's why we should use network functions. And that's why we should use network objects, okay? We cannot use functions from the network package to the iGraph objects. That's why we should create now network object. Okay, so to create this network object, we should have a matrix, right? So we put here that networks is a necessity. Okay, so we cannot like skip this part. So the first thing, we create a matrix. After that, we create a network. Okay, network objects. So we have like a simple number here. We have 15. We will have 15 nodes, okay? And after that, we will use the function matrix. And you see that here we have a matrix. So please tell me what is the meaning of this number here? Not okay. This number here. Okay, it's great.
Self loop.
Yeah, great. For those of you who like doesn't have this experience, we like should go from rows to columns. Yeah, always. It's like the very important idea here. From rows to columns, always from rows to columns. And you should understand like this number here that we have a connection from 1 to 3, again, from rows to columns. And we have this connection here, right? But you see that here we have a connection from 5 to 5. So we basically have a connection from the same loop to the loop that we like would like to have this connection. That's why we have a loop. It's really interesting. So I will like show you that you see that here, for example, we have this argument called loops equals to false, but we can skip it actually, or we can like put true here to see these loops. And I want you to not be afraid of them. It's like okay, so here we have our matrix. It's all right. And also you see that we put null here to the main diagonal to like skip the loops, because mostly we like loops are really bad, because most of the methods that we used in social network analysis, they assumes no loops, like okay, no loops or multiple lines in our network. That's why it's a really common thing to get rid of like these loops and go like further. Okay, so we will not put it here, and we will put the here true to see these loops. And to see that, we can check the dimensions. These dimensions of our matrix should be equal, okay? Because our network is quadratic, and you should remember that. And if the network is quadratic, the dimensions should be equal again, right? So the number of rows should be equal to the number of columns. That's why we always check this thing, because if the dimensions will not be like equal, it will not work out. Okay. So so here we apply this function as network. We can also use network function, and so we should place here our network object, okay, our matrix object, okay, matrix objects. After that, we should specify whether the network is directed or not. Yes, and you see that it's really important for us to understand this is directed or not. But my advice for you is to put always true here, because you never know. Or you should apply is-symmetric function before to like be sure that you like do not commit a crime. Okay, so we put loops here true and matrix type adjacency. Okay, so there are lots of matrix types, but okay, for us it's like okay, adjacency. Okay, and we have just created our first network. My congratulations. And you see that network size is 15. We have like this summary. You see that there are 15 vertices. There are some loops in our network. Our network is directed. There are no multiple lines. It's not bipartite, meaning that there is like all the vertices are from the same group, not like conferences and students, okay? There are no missing edges, meaning that we do not have like these NAs in our basic network object, okay? And we have a density here, meaning that it's also really important. Please pay attention to this fact. 49% of all possible edges is present, okay? 48%. So we have almost a half of all possible edges, okay? We cannot like assess this number. We cannot say like this is big number or small number. No, we should just say that only a half of all possible edges are present. Okay, and the most interesting thing here, we can plot our network. And you see that here we have loops. Well, one might say that you see that there are lots of connections, but you see that only a half of all possible ties is present. You should just feel this, okay? And we have lots of loops. For example, this one has a loop, this one has a loop, this one has a loop, but you should like know that it's okay. Sometimes we have loops. Okay, and here we just created the network from scratch. We just built it with our hands, but in most cases, we like already have network data. And network data may be in different formats, and today I will show you some of them. For example, as I told you yesterday, Daria was teaching you Pike, and you see that in Pike we have specific types of data. You see that here we have DRACnet 2Py, and it's really specific type of the data. And to work with this type of data, you should use the library called foreign, and you see that we can read this network. We can see that within this object called DRACPy, there are two objects. These are networks and partitions. So networks are like graphs, so it's like basic structure up, and partitions are our attributes. So we can basically like have this network structure that we can get from networks, and you see that there is one network here, and we can extract this network, okay? And we can also check that this is a network, and we can plot this network, okay? So as I told you, you see that you have all the explanations, and I recommend you to like at least see something in this handout. And you see that I have a doubt. total edges in a directed graph -1 can, well, probably you have a mistake. So you see that it will be like the basic algorithm is to find the number of edges that we have in our graph. Like in our graph, in your case, okay, let's consider mine. Well, in my case, there are like 110 edges. Okay, so we should put this number here. And we should divide this number to the possible like number of edges. The possible number of edges, if I am not mistaken, it's like 15 multiplied by 14. Is it right?
Yes, number of vertices minus number of vertices minus 1, n multiplied by n minus 1, correct?
Well, why it is like, okay, let me put it this way. Okay, you see that the total number of like all possible edges is 110, right?
Okay, I understood now. I'm sorry. I calculated
we have loops.
in a reverse idea. It should be calculated by total edges present in the graph by total number of maximum edges that the graph can have.
Yeah.
So 110 by 210 is 0.4888. Correct. Sorry. Thank you.
Okay, it's okay. So okay, let's go further, and you see that here we have like in this handout you had all the explanations. Sorry, it's great. And you see that here you have like all the explanations, and I really recommend you to like read something from here. For example, you have like this really, I would say, interesting information about this network, because you see that, okay, we have a network, but what does it mean? So you see that this network is really like a famous network describing connections between well, it's drug users, okay, in Hartford. So here we have a network that captures the information about drug users, okay. But what do you think? Do you think that it's typical if we like know that it's like drug users network? What is strange? How do you think? What do you think?
There are a lot of dots without any relationships with other.
Yeah, and if we know that it is like drug users network, I think that it's quite uncommon. Like it's quite uncommon that people use like drugs with alone without connections. Okay, and maybe not all the data is collected, and there are some questions, because you see that it's quite uncommon for like social patterns, maybe for like I think that those, not me, but according to like studies and research, those people who like use drugs, they sometimes, in most cases, they're not isolated, because there is some kind of community, okay. But this is like really, you guys right, and you see that there are lots of isolates here, and it's quite uncommon. And if you have like this network in practice, the very like common and general thing is to like remove all the isolated vertices, because we do not have like lots of information behind these isolates. So, okay, this is really uncommon. And you see that we have like specific attributes. We have this ethnicity codes. We have this African American, Puerto Rican, white or other. We have this gender codes, male, female, and like this is our like characters of every person. And yeah, this network is quite specific, right? So there are 293 vertices, yeah, here. We have this number of edges, 333. We have like lots of dyads. And you see that this number represents all possible pairs, right, between our vertices. And you see that as our network like gets larger, the number of dyads is expectedly like also increases. So you see that here we have like this also gender. It is a vector. Let me like show you this information. How many nodes, how many edges, and how many dyads. And also we have like this handy function called dyad census, if I'm not mistaken. Or sorry, dyad census. Sorry, dyad. Well, maybe I should restart R, but you should like put something like dyad census. Okay, I will. Sound safe. Okay. Okay. Sound safe. Okay, I will open it right now. Can be found. It's like really bad thing. Okay, great. So let me just open this network again. So here we have this really great function called dyad census. Oh. Okay, so I will fix it maybe after our workshop. Okay, so you can use this function dyad census. Maybe I should write it in your chat. Dyad census, as far as I remember. Dyad census.
Sorry, will you send the RMD file with the code after the workshop?
Well, I actually attached both files in the zip folder.
Oh, okay, thank you.
Okay, and you have like here gender, two attributes, gender and ethnicity, and you see that these two objects are basically vectors. So the length of the vector is like really like equal to the number of nodes our network like has. So it's also really important that the length of the vector should be like the same as the number of nodes that we have within our network. And yeah, here we are setting like attributes, and we can, after that, you can plot your network with this attribute. And I will save this part for your home task. I will see the results if you would like to like share the results with me. And yeah, this is like a really the picture you will get, it's like really great. And after that, we can consider the really classic example. It's like Florentine families. And you see that we have like two matrices. One matrix is for marriage ties. The second matrix of the second network is for business ties. And you see that there is a really great data set because the data is collected quite nicely, and the conclusions we can get from the data is really great. And you see that here we also have like attributes called wealth. Yes, wealth, the number of priorities, okay, and the number of business or marriage ties, okay. So this is the source of the data. You can also like collect this data from this source, but I attached this R data file to a zip folder. And here, as we are working right now as the network like a universe, you should understand that here we created a matrix, and after we created a matrix, we should apply the function called as network or network. And as we know that our connections are undirected by nature, because we have like this marriage connections between two people, we should understand and we should like put it directed equal to false here and here. And also we can set the attributes, and after that we can like create some networks. And you see that as we have these wealth attributes here, like it's like the number of how rich a particular family was at that time. And you see that there are like really wealthy families. For example, what are the wealthiest families? What do you think?
Bishcheri, Parsi,
Yeah.
Or probably Medici.
Well, I think that this family called Castellan is like wealthy, maybe. But you see that there is also a theory. It's like Moscow and like rivers. You see that I think that mostly everyone knows Medici, right, from this period, and it's like the most powerful family in Italy at that time. And you see that actually it's not the wealthiest one. Well, we like in general do not remember this Bisheri family or Pazzi family, but we do remember Medici, okay? Well, if someone like has a background in history, maybe they will help us with this understanding, historical perspective, okay? But according to the network perspective, Medici, this family has the highest between centrality and all the other centralities, because you see that this family possesses the central position within the network. Maybe the like parents was thinking about these marriage ties, and they like successfully marry the like several families, and that's why this family like became so powerful. So there are lots of many thoughts about this period and marriage in general, but it's a really classical example, and I would you to like know this example for sure. Okay, so here we have like business ties. This business network is not like really interesting for me. This network is like classic. Okay, so you should if you like if you will like get interested in the network analysis, you will find this network like everywhere. This was the first network that I saw when like I was like in the I was second year, maybe second or third year bachelor student, and this information just was mind blowing for me. So it's quite sentimental. So we can also import Uniset files. Uniset is really like also a popular program to work with network data. This is like the very same data, but in the other, like another format. And you see that we like apply different functions that are not like the same from the previous one, okay, but the information is totally the same. And well, this is the funniest thing. This is the funniest thing of my whole workshop. Well, I will try to fix my problems with R because it's like so bad and so like sad for me that I have like these problems with R. Remind later. Okay. Maybe everything will be okay. So we have this. So you guys are really great. I'm really happy that you actively participated in my like workshop, and let's have fun and let's discuss some interesting things regarding the network that we will construct right now. So can you see my screen now? Is it okay?
Yes, yes.
Okay, so we can construct the movie actually. This code. Okay, thank you. So this code was made by a bachelor, as far as I remember, students from HSC, and I really like this example. You see that we should here load the library called MDTV, and if you like don't have this library, you should put here install packages and all the other things that we did like a half of an hour ago, and you should install this library. Okay, I have this library on my computer. That's why I should only load this library, and it's okay. You see that it's also nice that everything is fine. And you see that we can create a list object, and we can contain like lots of many objects inside. You see? And let me create the magic. Activate. It's also okay. Don't be scared of these red lines. Flow color is not found. Let me load this object, flow colors, flow colors. Okay. Okay. So we can create this movie again, and I should load this information. You see that it's okay. It's okay. Because many people are afraid of the red lines. And you see that we can create a network movie. You see that we can press here button, this button, and we can start the movie. And you see that well, I think that firstly, it's really like great looking network. And you see that we can press this button, and we can see that we have lots of time slices, and this is like the process of this play. And yeah, this is purely magic. I missed the moment you solved the problem with colors. Let me press pause here. You see that previously my code like failed because I do not have one object right here. That's why you should go to the line 358, and you should just load these two code lines. You can just press this button here, and in your directory, this object will be in your directory here. And after that, you can just go to this chunk, line 457, and you can just run it, and you will have the very same picture. And you see that it's really great. Well, I have a question for you guys. What is the size of a vertex?
Number of incident edges.
Yes. So this is probably the main character. Yes, this one. And this one maybe is also really like a first or second row. Okay, so it's really great that we can create a network basically from everything, and I really like this fact about network analysis. Okay, and also we can create 3D plots. You see that here we can flow marriage. Let me just load this data. Okay, I just loaded this data. We can plot this really fancy picture and number of, not the number, but the size of the nodes of a node is wealth. Yeah, so the higher the larger the vertex, the wealthier the family. Okay, and also we can create 3D plots, and let me show you like this example. You see that here I just created this 3D plot, and I can drag it, and you see that this is like chemical, I would say, object. And here we have like this Pucci family, and we like have this big family. Well, it's not really like the best way to represent your data, but it's really fun. Yeah. It looks like really chemical something. Not the best layout, but I think it is fun. Okay. So, and the final part of this funny like concluding part is Harry Potter. Okay, so I hope that most of you have like watched Harry Potter series, and I hope that you will help me with the interpretation. Okay, it's okay. Our library is loaded, and I should load the data. This data is in the CSV format, and it's also quite nice. We can explore the data. You see that we have like ID of a character, name of the character, like this is Regulus Black, and we have like the description of this character. For example, we have like the Sirius Black, best friend of James Potter and the godfather of Harry. Okay, Also, we have the Cedric Diggory participated in the Tree Wizard tournament and got killed by Voldemort. Okay, and we can search for particular characters like Hermione. Hermione Granger, okay, and this is like one of the Harry's best friends and Mary's Ron Weasley. Okay, and also you see that we have like gender here. Okay, and after this really fast data exploration, we can create like this iGraph object. And you see that previously we used a function called as-network to create network object, but right now we are going to work with iGraph object. And you see that here we have like HP links. Here we have like this this edge list from node 1 to node 11, and this is like the foundation of our iGraph network object. And you see that here we have these HP links, we have like vertices, and our network is not directed. And we can plot our network, and you see that this is not like the best representation of the data we have. That's why I load a really special great library for you. Here I just used the opportunities of the iGraph package, and you see that using iGraph you can create such an amazing and like really nice looking graph. It's not dynamic, it's static, but you can attach this, for example, picture if you will like have a desire to publish a result in the journal or something like that. Okay, so it's like okay. So the picture is quite nice. Maybe the font is not really like the best, but it's quite nice. And after that, we can also calculate edge density here. Who can interpret the result? What can we say about network density?
It is not
Sparse
one.
Yeah, approximately like 20% of all possible ties are present. And this is everything that we can say here. Okay. Sparse net. Well, we cannot say anything actually, because let me just explain it to you. You see that if you would like to say that this network is dense, or it's like really tightly connected or something like that, if you would like to assess the density of this network, you should compare the network, this particular network that we have, with a typical network with this size. So basically the main algorithm that lies behind this procedure, you should construct many networks. Maybe you should construct like, I don't know, 1,000 of networks with this size. And after that, you should like calculate the density of these 1,000 networks. And if your network is like, if your density that you have like in your network is typical to this network structure, you cannot say anything, because it's like typical that your network has this density. But if your network result, like density, is really uncommon based on this comparison, right? Then you can say that, yes, your network is like really dense, or okay, your network is really sparse. Okay, so I hope that you got the idea, but this is like more advanced methods, and you will definitely use these methods, or if you like continue your education in network analysis field. Next, we can find the mean distance. So the mean distance between two random characters in our network is like 2, almost 3. We have a diameter. Maybe someone remember what's the diameter?
It's like the longest, shortest way, or how it is called, like.
Yes, you're right. Perfect. Okay, and so we can calculate centrality measures. Well, I will skip this part because it's a really big topic and I do not want you to like, whew. But I would like you to like play with me with the network visualization, because I like opened this interactive visualization library, and I think it's quite good. Let's see. So you see that here we have this network of Harry Potter characters, and we can see and drag all of the like vertices that we are interested in. And you see that here we have like lots of characters. Let me show you something interesting about this network. You see that we have this really isolated vertex, and the connection in this case meaning the support. So if two characters like have this connection, they support each other, and the like thicker the line, the like higher support between these characters is. Okay, so you see that Rita Skipper, I think that she is a journalist, right? She is a journalist, and yeah, it's quite it's definitely an isolated character. Also, we have this Tom Riddle and Mary Riddle. I don't remember those characters. Maybe you will help me. Okay, maybe not all of you watched this series. Okay, so and you see that we have like lots of characters. They are somehow connected. Oh, okay. Thank you, Olga. Thank you very, very much. And we can actually, for example, find some like communities, as I told you, and when we like considered examples. And here we used this cluster edge between this algorithm. It's like the most popular cluster Louvain. It's like also really great, and it's really fast. And you see that here, for example, the modularity coefficient is really like high comparing with this coefficient. So we should definitely use this cluster Louvain algorithm to like identify communities that we have within our network. And also you see that using this cluster Louvain algorithm, we can say that there are 8 communities here. Community number 1 consists of 15 characters and like etc. So okay, we can save this information, and can we cluster teachers? Well, you see that from if we like have this theoretical clustering from the something that we would like to like separate, okay, we can have like an attribute that is called teacher or not. It's also like interesting, and you can do it. Actually, you can publish your results, and you see that this data is like the basis of a really like great research in the really cool academic journal, and you can like actually analyze Harry Potter network data and like get a publication in the really great journal. but it's like another story. But here, community detection based on the algorithm. It means that, well, how can I describe you really like in a really easy way? So basically, this algorithm is trying to find such a number of communities that the modularity of this thing to modularity be the highest. It means that well, generally we would like a situation when we have like one like let me show you the presentation. Okay, so you see that from this picture, you see that for us it's a really perfect situation when we have lots of ties within the subgraph, but not so many ties with all the other nodes. So this community is like quite perfect because if you like, if we will have a link here, it will mean that all the possible ties are present. So for we are searching for this really optimal situation when we have as high number of ties as we can within a subgraph, but not so many ties between the communities. And yeah, here, for example, we clearly like have this number of communities equals to 3, but in our network it's not like so obvious. And you should just understand this idea that the number of ties within a subgraph in a community like here should be like really like high, but the number of nodes links between communities like here, it should be like really small. And these algorithms are trying to find this optimal situation. So it's based not only on it actually doesn't based on like knowledge that we have like Harry Potter characters. Well, it doesn't matter because we have a network. This network has like a structure, and this algorithm is trying to find some communities within this network. So here we have a hypothesis that if like people or actors in our case, they behave similarly, they will be like in the same group. So it's interesting to like check, is it is it like okay that we have a particular community or not? So let me show you the result. So okay, we have like this information, it's not really interesting. Okay, let us check the result. For us, it's really like important to give a really like great interpretation, and please help me with that. You see that I know that Lord Voldemort is like a really bad guy, and I think that all of you know that also. You see that all of the guys here are really like bad. And you see that these guys are really like tightly connected because the weights between like the weights on this line is really high. But you see that these two guys are really important because they kind of link two separate parts of our network. You see that Severus Snape is a really like this character has a really strong connection with this really bad person, Vincent Crabbe, but at the same time, this person like is connected with all the other like good guys. Okay, and you see that here we have Ron Weasley, Hermione Granger, Harry Potter, and you see that those vertices are like the biggest because they are the main characters. Okay, we have like a Dolores James is also quite important here. Let me check this information. Dolores James. Dolores James.
A link from Argus Filch to Dolores James, blue to green.
I think Dolores. It's like
You're there. Argus Filch to Dolores James, Umbridge.
let me please find this.
It's on the left. It's blue to green.
Blue to green. Oh, okay. This one, okay. Yeah, I think that, yeah, you're right. I think that this actor is also really important. And you see that it's kind of a bridge between these groups. That's why it may be important. Yeah, you're right. And what else? What can we say here? We can, interesting. Well, here we have like 4 components. This is the giant component, and these are like really small ones. We already like discussed that read the skipper-reads and isolase, and you see that we have here is a full triad, so all possible ties are present, and you see that we have loops here. So it's like Dursley family, and maybe, well, what do you think? Why do we have loops here? Maybe they are egocentric.
World,
What?
because they're not connected with the magic world, or what do you mean?
Oh, maybe it's a good theory.
No, it's aren't they both like parents?
Oh, maybe. But I think that they are maybe egocentric because this is like a support network, and maybe this is something that we should know about this egocentricity. But we should go to the ego is huge. But
What do colors mean?
colors, these are like communities. So previously we like make this community detection algorithm that is called cluster Louvain, and based on connections that every actor has, this algorithm detected 8 communities. Okay, so within the network there are 8 communities that are really like so actors within the community should be similar. Okay, so we can say that those Dursley family, they behave like in a similar way to each other and to the other network. You see that they are connected. Okay, here, and also at the same time, every actor doesn't have like connection to like any node here. That's why they're similar. Okay, the same situation here. Okay, also we can see that the way these actors behave also can like have we can make a conclusion that they behave similarly. So they are in the same group not because they are really like bad or something from the theory, like from something that we know from the movie, but they are in the same group just because they behave similarly to the actors. Okay, and I think that this picture is quite nice, and we can select groups and to see that these communities like full of bad guys: Peter Pettigrew, Lord Voldemort, Lucius Malfoy, and all the other guys. And also, we have like separate communities. Well, maybe there are not so like specific. Maybe we should join some communities, okay, from theoretical level. Those are good, but that. Yes, you're right. Well, let me check it again. Sirius Black, James Potter, Pippin. Yes. Okay. So this is like the second big community. We previously considered this bad guys community, and here we have good guys. And you see that Igor Karkarov is quite debatable person, because this person has connections with both parts, yes, but still it is good according to the algorithm.
Also, Severus Snape was like partially protagonist, but also antagonistic. So
Yeah. And for me, it's quite surprising that Neville Longbottom, Neville Dolgopoops in Russian, that this person, this character, like has such a like strong connection with this part. Okay, so yeah, and also Argus Flitch is quite debatable, right? Okay.
are the green ones teachers in this case?
No, these are communities. So according to the Lavane algorithm, those characters like behave similarly to themselves and to the all other nodes within our network. So it's not like something connected to the theory, to the knowledge like of this Harry Potter series.
Okay, okay.
Based only on connections and on the network structure. Barty's Orchid novel. Okay. Thank you, guys. It's so interesting that some of you know some particular details about this Harry Potter series. Do you see that we have like a really small community? It's also like a family. It's like this one, but I guess that these guys like parents of Neville. Okay, what's interesting? Well, I am interesting right now in this group. Let me check it.
It's one family, isn't it? It's all Weasley.
Yeah, it's a clique. Well, in social network analysis, it's a Weasley family. It's so interesting. So in social network analysis, one like concluding remark here, the final new words for you today is a clique. Clique is a like subgraph, like we just like have here. We have here, right? It's a part of your network where all possible ties are present. Okay, all the possible ties are present. So you see that all the vertices here, all the vertices here that we have, like from Molly to George, they are all connected, and this is like a really dense part of your network. And sometimes we're interested in finding these parts because this is like where the action is in our network. But you see that here they are connected because they're family. Okay, but you should remember that this is a clique. Fully connected subgraph is a clique. Yeah, that's right. So it's a part again of your graph where all possible ties are present. All possible ties. So we have. Sorry, it's my groupmate. Okay, so it's a clique. It's also like interesting, and I can understand it from the theoretical level. So I would like you to know here that even though we just can have like some communities not based on the theory, but on the way they behave. So algorithm like doesn't know that this is a family, but it turns out that they behave similarly to themselves and to the other like vertices within the network. And so we can say, yeah, we can say that this is a community because they are family. And we can understand it from like theoretical level. So we can interpret the results, but the algorithm doesn't know that they're family, but they behave in such a way that we like an algorithm decided that they there is a family. Okay, so you should definitely play with that, and you just, if you like this Harry Potter movie, you should just play and see the result that we got. So I guess that this is pretty much it. Maybe you have like some questions about our today. Okay, so we have a question. Okay. If your matrix is to be quadratic with rows and columns representing the same elements, okay. Oh, it's a really great question. Thank you for this question. It's a really deep question, and I'm really happy with it. Yeah, you see that basically we have two files. One with the network and all the stuff. Like you see that, for example, we have like this matrix. It's this matrix represents the like food trade relationships between the countries. And you see that here we have only connections. We have the labels here like Algeria, Brazil, China, okay. But we do not like have attributes. But it's like really great question. I'm so happy with it. But we have like additional file always. So we have like some matrix format. It can be like ANR-List, but in most cases it is a matrix like in this case, okay? But you see that we always have this additional file that is called trade. In our case, this is trade add, where we have like it's a data set. So it's important that if you would like to store a matrix object, it should be quadratic matrix again. But your attributes should be in a data frame, okay? So the number of rows should be like equal to the number of vertices that you have, and you should have like here vectors, and you see that, and you should remember that data frame is like it's like a collection of your vectors if your like rows are the same. And you see that you can like extract the second column, and it will be a vector, okay? So basically you always have this matrix, and additionally you always have this attributes file where you have all the attributes, and it's like the best way to store the data, because you cannot put any information here, okay? So it's a graph, it's the basis of the graph. But to work with attributes, to make some inferences, to like make conclusions, you should have this additional file trait attribute, like in our case, but it's like always an additional file. Thank you for your question.
No problems with any values in GNP here?
Well, we have here missing values, right? So your question is about this missing value, right?
Yeah, if there's a missing value, then what happens? Sorry.
Well, it's not a problem. So if you would like, for example, to add this attribute to your network, it will not be a problem. So it actually depends on the goal of your analysis. For example, if you're interested like in plotting the network, it's like no problem. But if you're interested in more like advanced methods of network analysis, like I don't know, well, we have like a method that is called network autocorrelation. Maybe you heard about it like in more geographic fields. But we like have this parameter that is called network autocorrelation. But if you apply a special function like to calculate Geary index or Moran index, you should always put in the attribute file, not in the attributes within function, that you have missing values, and it's okay. So it will be great for you to understand that you have these missing values, but in most cases, it's not like a problem. And you see that we can have here even it's a tempo. I remember that. Okay. Well, I'm really happy. I'm really happy that I spent this evening with you guys. You're really amazing. I'm really glad that you participated during my interactive part. And so we shall have in both tables the same first column. Well, actually, yes, but it doesn't matter, because you should just be sure that this like nodes, they are really like in the same order. So yeah, it will be safe for you to like have the same labels here, because sometimes they are mixed and it's like a really big problem in network analysis. So yeah, for you, the safest way for you to like store the data and be sure that everything is just right is, yes, to just put labels here. And yeah, but it's not really important, because at the end of the day, you're interested only in this values. Oh, guys, you're the best. Well, actually, I'm just a really resilient graduate student of this program, and I would like to share with you my experience. And I think that, well, I came to this program as a really motivated student, because I fell in love with SNA, and I'm really grateful that I still have this interest, and I just feel that I found my field, I found my place, and yeah, I'm really excited about teaching and sharing this interest. So I will be glad if you have any suggestions, and if you would like to ask the questions that I saved to you in this handout, you are really open to text me. And you're guys really the best. It was really the best way to spend this Wednesday evening. So I hope that you also feel it. Thank you.
Anna, thank you very much for your inspiration. Yeah.
You can text me. Well, I think that in the theory, when we have these slides in the theoretical parts, I saved my Telegram and email for you, so you can find me here, and I'm really open to all of your thoughts, suggestions. So yeah, Yeah, it's me.
Mhm.
So thank you guys again. Thank you, Daria Vasilyevna, for listening to me.
No, thank you, Anna. Thank you. It was a pleasure. Thank you very much. I think that this two actually today it was a very interesting day, and I think that it was really nice to see how we can work in Gephi and in R, and so we can now compare, find some differences. And Anna, thank you very much for this interaction part. I think it was it was great.
Thank you.
Yeah.
Thanks everyone again.
And thank you. Actually, you exceeded the time for almost 40 minutes. So poor you.
Sorry about that.
No, you're not. I mean, you just worked so hard. So thank you so much for this.
Okay, it's
Yeah,
also,
I think all of us appreciate your involvement.
yeah, thank you guys.
Okay, so now I will stop the